Sir, it's 4. We should start.
Good afternoon, everyone. Welcome you all to yet another session of a webinar presented by Skywatchers Association of Kolkata. I'm really honored to welcome you all to this very new platform that Skywatchers Association of Kolkata is organizing. Since the situation has compelled us to stay indoors as much as we can, so why not make the most of it? And we are very grateful to persons like Professor Sengupta, who joins us in these platforms to share their vast knowledge with us. We are really indebted to them. Thank you, Professor. Thank you very much.
Thank you.
Now, before not making this introductory lecture an elongated one, I'd like to say something like the topic of today's lecture is so exciting in itself that I just can't wait for Professor Sengupta to start. The topic is the exciting exoplanets. Now, why? For me, exoplanet was a planet just like us, fine. But why is it so exciting? Now, the study of exoplanets is so exciting because it gives us a look into our solar system, how it works. We try to know the solar system, how our planetary system works by looking at similar planets outside of the solar system. But there is one more point to it. The Dajus, the ETs, the aliens that we know, if they do exist, there ought to be a place where they live. There ought to be a place where they stay. The hunt for exoplanets has that dimension also. Now, a request to everyone during the session, please do not interrogate between yourselves. It becomes quite a nuisance. It's disturbing not only for yourselves, but for the lecturer, whose full concentration is on teaching us what he knows. Do not intercommunicate among them. Once we find people communicating amongst yourselves in the chat box with any topic related to this or any other topic, we'll have no other option but to block him out. Please do not communicate. And the final words, which are very pertinent, is these times that COVID-19 pandemic is creating a havoc. Please be safe, remain indoors as much, practice social and physical hand sanitizing, washing your hands, important, because prevention is far better than cure. And finally, please do not treat COVID-19 patients or patients infected with this corona as aliens. They need our support. With these words, all for joining us. I'm handing it over to the court, who will take you through the remaining part of the session. Thank you.
Let me thank you once again, Shoykot sir, for a nice introduction, welcome address to our 4th webinar. Again, we all have gathered for another webinar, the 4th one, organized by Skywatchers Association, but this time it's Sunday, not Saturday. In the previous webinar, we heard about our own star, the sun. Today, it's time to go beyond our own solar system. So the planets, those are far away. And to talk about those exoplanets, we have amongst ourselves an eminent person, Professor Sujan Sengupta of Indian Institute of Astrophysics. It is our honor and privilege to have Professor Sengupta amongst us, and who have kindly accepted our request to give the talk today. For a brief introduction for him, an eminent personality like him doesn't need one, but still, After the completion of his post-graduation in mathematics from Burdwan University, Professor Sengupta joined Indian Institute of Astrophysics as a CSIR research fellow. And after obtaining his PhD, he has done postdoctoral research at Vanderbilt University, Nashville, USA, with a NASA fellowship. He is now a professor at Indian Institute of Astrophysics and a member of the International Astronomical Union. His research activities include theory and observation of extrasolar planets, brown dwarf, neutron stars, and low mass binary stars. Currently, he is the only scientist in India to work on extrasolar planets. He pioneered the polarimetric method for detection and characterization of exoplanets and brown dwarfs. Professor Sengupta was one of the signatories, along with some greats like late Professor Stephen Hawking, Professor Frank Drake, Professor Kip Thorne, of the Breakthrough Initiative project established by Yuri Milner that search for extraterrestrial intelligence. And as I read, the list just goes on. He also collaborates with NASA's Ames Research Center Jet Propulsion Laboratory, Caltech, and he has very he has research papers published in peer-reviewed one of the most reputed journals. He has also a book published by Springer Publication, and we are really privileged, sir, that you have joined us today for the lecture. Uh, Before going into the session, I would like to just relay the instructions for the participants to please abide by these instructions during the lecture session for the smooth conduction of the program. First of all, please, I am telling you again that mute your microphones and turn off your video, please, and do not ask questions in between the lecture session. If you have your question, please put the question in the chat box. At the end of the session, we will have an interactive session with Professor Sengupta, where we will pose your questions to him that he will answer. And when Professor Sengupta will present his talk, you will see a tab in the people's list named presentation bearing the name of Professor Sengupta. Please click on the presentation tab and pin to it so that you can see the presentation clearly without having any difficulty. If there is any technical difficulty or problem, please post it in the chat box. Maybe it is some internet problem or connection problem. Wait for a few minutes. Hope it will get resolved, or we will try to resolve it as soon as possible. Please bear with us in that case. And one more thing, at the end of the session, we will provide a feedback form link in the chat box, and we will also provide the feedback form link in the YouTube live streaming live chat also. Please do fill that form up and submit it, because we will issue the e-certificates on the basis of the feedback form only. And now, without just talking for a longer period of time, I would like to request Professor Sengupta to please take charge of the session and deliver his lecture. Sir, if you please.
Hello, everybody. Hope you all are doing fine and taking necessary precaution. A nano-sized, semi-living creature has challenged the might of the most intelligent species on this planet. But I am sure that we will soon overcome this pandemic situation. Now, going to the astronomy. I think many of you have watched the night sky through telescope, through binocular, or even through unaided eyes. But have you ever lied down a grassy open lawn or on the roof of your house in a cloudless night sky? If you do so, within few minutes you will be immersed into the vastness of the cosmos. You will feel humble. Your posturings, your self-imagine importance, the delusion that you are privileged or underprivileged, weak or strong, poor or rich, wise or fool, all will be dissolved into the vast emptiness of the cosmos, into the darkness of the sky. And you will start asking, who am I? What am I? Where am I? How have I come into being? and you will feel extremely lonely. You will become curious to know if anybody out there watching you from one of the millions of stars twinkling in the night sky. I'm sure all of you have heard about alien, about extraterrestrial intelligence in science fiction books, TV serial, movies. Today, I'm going to tell you the systematic scientific quest for and possible answer about that question, if we are alone, or we will address inadvertently how lonely we are. Thank you, Sky Watcher Association Kolkata, for your kind request and for offering this opportunity to talk on that. Thank you, the admins of this association, for their tremendous help in teaching me how to use this platform. And let us now go to the I hope this is okay. You can see it.
Yes,
So,
sir.
So during the next 1 hour or so, I'm going to tell you the exciting extrasolar planets or the wonderful world out beyond our own world. This is right.
Yeah.
Well, let me repeat. So during the next 1 hour or so, probably less than 1 hour, I'm going to tell you about the exciting extrasolar planets, the planets around another stars, another sun, the wonderful worlds beyond us, in order to unveil the status of the present understanding of that eternal question, are we alone? Now we know one planet for very sure, that is our Earth. That's where we live, that's where we exist, that's where we survive. Now for 2000 years, we believed in Aristotelian concept that this planet, the Earth, is the center of the whole universe. But then when more observational evidences, more analysis was available by various astronomers like Galileo, Bruno, Kepler, etc., then we abandoned the Aristotelian concept and accepted the Copernicus theory that the sun is the center of this world and not the Earth. But Copernicus actually thought that sun is not only the center for its planetary system, but also the center of the whole world. It is during the 19th century we came to know the actual picture of the universe, how vast is this universe, and we understood that the sun, is just an ordinary star among the millions and billions of stars hovering on the night sky. So as soon as we understood that the sun is a star, we realized immediately that in that case, the millions of lights in the night sky are also similar to the sun. And if that is the case, then definitely they should have also planets around it. And if they have planet around it, definitely some of the planets are like our Earth. And if that is the case, if a few planets are similar to Earth, then there must be possibility that they also harbor life. So that generated the curiosity, that generated the interest among not only the common people, but also the astronomers. And the search for another planet outside the solar system begin. But because there was no good telescope at that time, the technology didn't advance sufficiently at that time, there was no computer, so people could not detect such type of small object in the vast universe. But in the first false positive of exoplanet came out, you will be proud to know that from India, and that is Madras Observatory, which existed between 1786 to 1899. It was established by the British East India Company for meteorological purposes, but then it was activated for astronomical research. Now, in 1855, the director of this Madras Observatory, he found that a binary star, that is a system of two stars called Ophiuchi, 70 Ophiuchi, they are not following exactly the Kepler's law. So he first calculated and told in monthly notice of Royal Society's journal that if there exists a Jupiter-sized planet in this system, then that can explain the anomaly in the motion of these binary stars. And at that time, such type of concept, such type of realization was completely revolutionary. Of course, 50 years people thought that there must be a planetary object, but then later on it was found when more sophisticated telescope and computational facilities were available that Jacob made some mistake. He probably didn't include the effect of the Earth atmosphere. But till now, this is considered to be the first scientific attempt towards finding out an extrasolar planet. Then this discovery, this report, this concept motivated many astronomers, and they all started searching for extrasolar planet, but in vain. Finally, in 1995, this gentleman, the Swiss astronomer Michel Mayor, and his PhD student at that time, Didier Queloz, reported the first discovery on extrasolar planet around the star 51 Pegasi in the constellation of Pegasi b. Now, if you see, if you watch by a powerful binocular or a telescope, you can see this 51 Pegasi is a point object in the sky. So the planet doesn't have their own light, and they are hidden by the immense brightness of the star. Therefore, it is not possible to see the planet directly. And therefore, the astronomers take indirect measure. They try to find out the effect of the planet on the star. And that's what Michel and Didier tried to do. So what they did is a method called radial velocity method, or sometimes called Doppler method. Now, when two celestial objects orbit each other, they don't orbit around any of their center, but they orbit around a common point, which is called the barycenter. Now, if one of the object is heavier than another object, then this barycenter, this red plus, that moves towards that heavier center, so heavier object. So if there is a star and a planet, then what happens? The center of the motion, that is the barycenter, it is located inside the star, but not exactly at the center of the star. As a consequence, the star also gets certain motion. And if this system is happen to be edge on for the observer, then there is a wobbling of the star, that is, the star is going away from us and moving towards us. Now, from detecting this motion, this movement or the wobbling of the star, astronomer confirm the presence of a planetary object. But this movement is very tiny. It's about 30 meter per second for Jupiter, that gives this type of motion to Sun. Even 10 centimeter per second that Earth imparts such type of motion on the Sun. So how the astronomer detect this tiny motion? Now, they send the starlight through a sophisticated and complicated instrument called spectrograph that splits the light of the star into several colors corresponding to the wavelength of the starlight. Now, if the star is static, there is no movement, but if the star has a motion, then the entire spectrum starts moving. When the star moves towards you, then the spectrum moves towards the blue region of the wavelength, and if it moves away from you, the spectrum moves towards the red region. This is called Doppler effect, and this shift is called Doppler shift. Now, in the spectrum, there are a few dark vertical line appears. They are called the absorption lines. They are caused because the starlight get absorbed by the atoms and the materials in the outer region of the stars. So astronomers pick a particular such type of dark line or the absorption line and monitors its static laboratory frame. You can see that if the star doesn't move, then the line should have been situated in this region. But when there is a motion, when there is a radial motion, these lines move periodically. From this, they confirm the presence of a planet. So Didier Michel and Didier Queloz, they developed a very sophisticated instrument called LOD, which could detect such type of Doppler shift, which can be then converted into the radial velocity. And thus, in 1995, they confirmed the first extrasolar planets around a sun type of star. And because of that, last year, they have been awarded the Nobel Prize in Physics. Now, after 5 years of discovering the first exoplanet, another method was used, which is called the transit method. Now, I think many of you have witnessed the transit of Venus across Sun. Last year, there was a transit of Mercury across the Sun. This transit of Venus is very rare. Now, when the planet Venus crosses, it travels over the Sun, the disk of the Sun, its shadow falls over the disk of the Sun. And subsequently, what happened? The brightness of the Sun decreases, although very insignificantly. Now, what the Venus is about 115 times smaller than the Sun. Now, imagine if there is a Jupiter size of planet very near to the star. Jupiter is 1/10 of the size of the Sun. Then what happened? This drop in the brightness of the star is significant and can be detected by our imager, by our instrument. So you can see that when the brightness of the star should have been straight line constant, when the planet transits across it, there is a significant drop in the brightness. So the astronomers detect this periodic nature of this decrease in the brightness and confirm the presence of a planet. So from our Indian facilities, by using our own telescope like Himalayan Chandra telescope, me and my PhD students are also regularly monitoring such type of brightness decrease in various stars. We are trying to follow up already discovered planets, or at the same time, we are trying to search new planets. Now here you can see that these red lines, these are the brightness of the star at the different time of the same night. Now, if there is no planet, then this could have been a straight line. But because of the presence of the planet, when the planet transits and it blocks the star, there is a significant drop in the brightness. This observation is done by using Jagadish Chandra Bose telescope at Vainu Observatory, Kavalur, by my PhD student Aditya Chakraborty. So by this way, by using the transit method, we are also trying to follow up the already discovered planets, and we are trying to discover new planets. Now, there are many other methods also in addition to Doppler method or radial velocity method or transit method. There are gravitational microlensing method, there are pulsar timing method, there are astrometric method. The method that I have suggested a decade ago is by exploiting a particular property of light, which is called polarization. Now, what is polarization? For that, please watch this video, which is prepared by my collaborator at Jet Propulsion Laboratory of NASA and by the Caltech scientists. unpolarized. However, are in direction polarized. A device called a polarizer lets us measure light polarization. A polarizer allows light of the matching orientation to pass. It blocks light of the opposite orientation. Unpolarized light will pass through the polarizer at any orientation. Now, how does light become polarized? Light becomes polarized either by the presence of a magnetic field or when light scatters off of a surface. A properly oriented polarizer can block this reflected light. Light can also become polarized from scattering off of gas and dust particles in an atmosphere. You can see this effect in the sky by rotating your head while wearing polarized sunglasses. The amount of light that gets polarized tells us about the gas and particle properties in the atmosphere. Polarization studies have helped us understand the atmosphere of the other planets in the solar system. The unpolarized star light becomes polarized when it scatters off high altitude haze or cloud in the atmosphere. However, if the atmosphere is uniform, the cloud is distributed homogeneously, or if the object is perfectly spherical, then the net polarization becomes zero as the polarization in all directions cancel out. But if the cloud is distributed inhomogeneously in band-like structure, or if the object is oblate because of its rotation on its own axis, like our Jupiter, Saturn, or Earth, then the net polarization becomes non-zero. On the other hand, if a planet transits across a star or a satellite or exomoon transit a planet, then also the net polarization can be non-zero. Now, this method has been confirmed observationally by applying it to another object called brown dwarf, which is very similar to Jupiter type of planets, but they are born like a star. They are actually intermediate between the stars and the planets. They are born like a star, but they fail to become star. So they are neither planet nor star, but they are intermediate to the realm between the most massive planet and the least massive star. So right now, NASA and the Europe. Yes. Yes, here. Acha. What is polarization? Is that fine? Technically speaking, polarization is the measure of the anisotropy of a radiation field.
Yes, sir, it is fine.
A wave of electric and magnetic fields. These waves can be oriented in any direction. Hello? The direction of each wave. Is that okay?
Yes, sir, the sound is coming fine.
Okay. Wave's oscillation is called its polarization. Most light sources, including natural light, produce randomly oriented waves. We call that light unpolarized. However, if the light waves are in the same direction, we say they are polarized. The device called a polarizer lets us measure light polarization. A polarizer allows light of the matching orientation to pass. It blocks light of the opposite orientation. Unpolarized light will pass through the polarizer at any orientation. Now, how does light become polarized? Light becomes polarized either by the presence of a magnetic field or when light scatters off of a surface. A properly oriented polarizer can block this reflected light. Light can also become polarized from scattering off of gas and dust particles in an atmosphere. You can see this effect in the sky by rotating your head while wearing polarized sunglasses. The amount of light that gets polarized tells us about the gas and particle properties in the atmosphere. Polarization studies have helped us understand the atmosphere of the other planets in the solar system. The unpolarized star light becomes polarized when it scatters off high altitude haze or cloud in the atmosphere. However, if the atmosphere is uniform, the cloud is distributed homogeneously, or if the object is perfectly spherical, then the net polarization becomes zero as the polarization in all directions cancel out. But if the cloud is distributed inhomogeneously in bands-like structure, or if the object is oblate because of its rotation on its own axis, like our Jupiter, Saturn, or Earth, then the net polarization becomes non-zero. On the other hand, if a planet transits across a star or a satellite or exomoon transit a planet, then also the net polarization can be non-zero. Now, as I told that, this method has been confirmed by using it to an object called brown dwarf, and now various international group of astronomers, including NASA and ESO, are making sophisticated polarimetric instrument to employ this method, which can not only help in detecting planet, extrasolar planet, but also characterize its atmosphere and its property. Anyway, in any case, before 1995, we knew 9 planets around our solar system, or within the whole universe, we knew that there are 9 planets. In 2006, the International Astronomical Union, after a lot of deliberation, decided that Pluto cannot be considered as a planet in the solar system. And this has been prompted not only because the Pluto is a very light object, even lighter than our moon, but also the discovery of a large number of exoplanets prompted the International Astronomical Union to decide that Pluto is not a planet. So we knew only 8 planets in our solar system. But once the first exoplanet, that is Pegasi 51b, was discovered, various astronomers, by using all whatever be the facilities or the telescope available in the earth, started hunting for planets, and very soon hundreds of planets outside the solar system was discovered. And that prompted NASA to send a dedicated space telescope, because in the space telescope are more efficient for discovering such type of planet. Now, once Kepler was functional, then we discovered a large number of planets outside the solar system, their sizes, their temperature, their properties, that has completely revolutionized our concept on planet. Before that, we thought that we know everything about the planetary system, and wherever there will be planetary system, it will mimic the solar system only. And also, we thought that we understood very well how the solar system was formed. But the large number of planets that Kepler discovered, that has gone beyond our imagination. We have started thinking that our concept, we have to re-study, we have to re-investigate about the planetary properties, planetary formation, about planetary evolution. Planets, those are bigger than Jupiter. Those are heavier, but 10 times heavier than Jupiter. And Jupiter size of planet that are very near to their star and so very hot. Planets which are slightly bigger than Earth, but similar to Earth, which is called super Earth, or planets which are between the Neptune and Earth. These are called mini Neptune, which has a very small rocky core in their center, but is a giant gaseous. That means which is an intermediate phase between a rocky planet and a Jupiter planet. Jupiter type of gas planet are discovered. And this has completely gone beyond our imagination. Now, I cannot tell you the wonder of all those planets we have discovered. Let us see the few most wonderful planets. Now, we know that our nearest neighbor is Proxima Centauri, and which belongs to a triple star system. The system contains Alpha Centauri A and Alpha Centauri B, which are orbiting each other, and Proxima Centauri is orbiting the Alpha Centauri A and Alpha Centauri B. Now, this Proxima Centauri has a planet, and which is very similar to our Earth type of planet. Now, imagine this planet, which has 3 parents. So, its day and night is determined by 3 stars. Its atmosphere, its environment, its season are determined by 3 planets. So, similarly, quite a few planets have been discovered which are called circumbinary planets. Those are orbiting 2 stars. At the same time, we discovered some planet which has no parents. They are just rogue planets. They are floating isolated. And most probably they were ripped out from their planetary system because of some effect. So they have no parents, but they are very young and they emit radiation in infrared, so we can detect it. Now, you know, the sun was formed out of a huge interstellar cloud of hydrogen and helium gas. Now, this cloud contained almost equal amount of carbon and oxygen. The amount of carbon is just half of that oxygen, and that's why on the Earth's surface or in the solar system, we see oxides much more. Like carbon dioxide, like carbon monoxide, like silicon carbide, etc. But if a star is formed out of the gas which has equal amount of carbon and oxygen, then it will be carbon rich. That type of star is called carbon rich. As a consequence, its planet, instead of silicon carbonate, it will be dominated by carbon rock or carbon type of material, carbon rich material. Now, under high pressure and temperature, this carbon surface can become diamond. Now, how carbon becomes diamond? Under the deep, some 100 kilometer deeper in the Earth's surface, under strong pressure, under tremendous pressure and tremendous temperature, the carbon molecules, they form a lattice, and that gives rise to diamond. Through volcanoes, this diamond comes to the surface of the Earth. Now, if a carbon planet is very near to its star, then because of the tremendous temperature, the entire surface can become diamond. Or if it is further away, then the entire mantle can become diamond because of the high pressure. Now, these type of planets which have a high reflectivity. Now, imagine that if there are quite a few, if there are 100 diamond planets in our galaxy, then how valuable, how expensive will be our galaxy itself. At the same time, there are planets discovered which doesn't at all reflect light. They are composed of such type of material in their surface that their reflectivity is very less. They are very dark. So the variety, the diversity in the properties of these planets has completely surprised us. But this picture that you are seeing it, these are artist concept. These planets cannot be discovered directly or cannot be imaged directly. But there are some planets which can be imaged directly, because these planets are quite young. They are of 100 million years. So they are still under the formation situation, and therefore they are so hot that by blocking their star in the middle here, is by an instrument called coronagraph, the planet can be imagined. These are the real picture. So here is 1, 2, 3, 1, 2, 3, and 4 planets we can see around a star. Now, these are all giant planets. These are all gaseous giant planets. These are all special planets. So our ultimate aim is to find out those planets which can harbor life. So where should we search? What type of planet can harbor life? So we have to search in the region of a star that is called the circumstellar habitable zone. Circumstellar habitable zone, or the Goldilocks zone, is defined the region at which the temperature will be such that water can exist in liquid form. So how that can be decided? Now suppose there is a extraterrestrial intelligent life, the extraterrestrial civilization, which are trying to detect, which are similarly curious to know if anybody out there, which are trying to find out if there is any life elsewhere in the in our galaxy. So they have the same curiosity, they have same intelligence, they have same knowledge, but their technology is much advanced than our technology. So very soon they will find out the sun is a suitable star, and they will discover all the planets, all the 8 planets in the solar system. And from the brightness of the sun, they will find out that 3 of the 8 planets, that is Mars, Earth, and Venus, are in a region that is known as the circumstellar habitable zone, where the temperature will be appropriate for water to exist in liquid form. But all these planets has a reflective property. So, for example, the Earth reflects 30% of the sunlight it receives into the space. This is called albedo. So, the albedo of Earth is 0.3. Similarly, the albedo of Mars is 0.2, because 20% of the sunlight it receives is reflected back into the space. Venus has a whooping reflectivity. 70% of the sunlight is thrown out into the space. So if the extraterrestrial intelligence find out this reflectivity of this planet, then they will find that no planet is appropriate to have water in liquid state, because all of them will become very cold. Mars is already very cool, and so 20% of the sunlight, if reflects, it becomes cooler. Earth, the mean temperature of Earth will become minus 15 degrees Celsius, and even the ocean will be frozen, and Venus will be much cooler also. So there will be no planet. But we know that here on the Earth we exist, and in fact water in all 3 different forms, gas, liquid, and solid form, exist on the Earth. So what they will be missing, and that is the greenhouse effect. So when the sunlight enters into the Earth atmosphere and it hits the surface of the Earth, it reduces, it loses its energy. The light energy that falls over the Earth's surface, that loses the energy, and it becomes infrared radiation. Now this radiation should have been escaped from the space, but while escaping, it faces the molecules like carbon dioxide, like water, like oxygen, and it gets scattered with these molecules. And after several times it gets scattered with the Earth molecule, it could not escape the Earth atmosphere, and thus it warmed up the Earth atmosphere by 30 degrees Celsius. And thus, because of the greenhouse effect, the temperature of the ambient temperature of Earth, instead of minus 15 degrees Celsius, becomes 15 degrees Celsius, and water could exist in liquid form. So NASA's Kepler mission, and at the same time the European Space Agency also sent a space telescope called Corot. They started searching for such type of planet which are located at the circumstellar habitable zone of the stars. That means where water could exist in liquid form. So NASA discovered very soon a planet that is known as Kepler 22b, which is located in the habitable zone of that star. But then it was found that the planet actually is much bigger than its density implies that it's not a rocky planet, it's a gaseous planet, or rather it's very similar to Neptune type of planet. But it is very essential to have a rocky surface in order to retain the liquid water. So NASA again started, or Kepler on other observatories or other astronomers also started discovering or finding out planets, rocky planets in the habitable zone of of a star. So very soon Kepler 20 was discovered, which is found to have the same size as that of Earth, and therefore it should be of rocky nature. But unfortunately, this planet is so near to its stars that its temperature goes as high as 760 degrees Celsius, so that even gold can melt onto its surface. The other planet in the same system, Kepler 28, has 425 degrees Celsius, and this is also too high. So water cannot exist in liquid form in this planet, although this planet should be rocky. So the search continued, and very soon several planets, rocky planet has been discovered, which are in the habitable zone of their planet. So their temperature is appropriate for water to exist in liquid form, and they have rocky surface to retain that water. So this has become quite interesting discoveries. But now the question is that, can they harbor life? Can these habitable planets, can these rocky planets in the habitable zone really harbor life? That will lead us to a more fundamental question: what is life? Now, by life, we understand only the life we see on Earth. There are millions of living species, invisible species, from amoeba to human being, from moss to banyan tree. There are many forms. But what is the definition of life? Unfortunately, there is no fundamental definition of life. See, if 400 years ago somebody had asked you what is water, you would have described only. Water is a liquid, colorless, odorless, it flows from up to down. But then another person will bring a glass of methyl alcohol, and then you will find out that it has also the same property, colorless, odorless, liquid. So description cannot give the actual process, or cannot give us the cannot distinguish us from one object to another object. But now, if somebody asks you what is water, you will certainly jump and tell that, oh, water is H2O. It is a molecule made by two hydrogen atom and one oxygen atom. Now, from this fundamental formula, from this fundamental definition, one can derive all properties of water, that it is colorless, odorless, liquid, and everything. Unfortunately, such a fundamental definition of life doesn't exist, because life is a process. So we have to only describe the life. Now, NASA has given a working definition of life that says life is a self-sustaining chemical system capable of Darwinian evolution. It doesn't say anything about the composition or the biochemistry of the life involved. And also, this is a description, so it can be questionable. Somebody can ask that an embryo in mother's womb is not self-sustaining, but it is life. But for the astronomer, we do not need to search for the embryo. If we find out the mother, it will be sufficient for us to tell that life exists in that place. But now, if we go slightly beyond this definition, we can describe life on Earth as life is an ensemble of organic materials. Organic materials means carbon-based molecules that are made mainly by carbon, hydrogen, oxygen, governed by a self-sustaining synchronized system of chemical process, that is our enzyme, hormone, and all those processes, and characterized by metabolism, through which the food converts energy, replication, through which a cell copy exactly another cell and transfer the information to the next generation, and 3, the evolution through natural selection. Now, this evolution through natural selection is very important. If we find out one cat or one dog on Mars or any other planet, then if we understand the evolution of natural selection or Darwin theory, then we can immediately realize that there must be many more cat and dog and many other species on that planet. But if we do not find, then definitely those cats and planet are imported from some other places. Now, this evolution through natural selection is actually a mistake by the gene in replicating a species. So, if in a long, for million years, there is a accumulation of error by the gene in replication, it gives rise to evolution, and not all species survive, because we know that Darwinism tells about the survival of the fittest. Now, the problem here is that we know that the laws of physics are universal. So, if an apple falls on Newton's head on Earth, it will fall on his head or somebody else's head in the corner of our universe because of the same laws of gravity. But unfortunately, we do not know whether the laws of biology are universal or not, because we know Earth, the life only on this planet, only on Earth. We have not yet discovered any form of life in beyond our Earth. Now, if life exists in other form, by other combination, say if life exists in carbon, life is made of carbon and it follows some other biological thing, then we cannot recognize that as a life unless and until it is an intelligent life and it tells us that, look, I'm also a life. But then what is intelligent life? That is also another problem, another dilemma. We determine the intelligence of a species by its behavior, by its response to the nature. So in that way, even chimpanzee, dogs, cats, octopus, all are intelligent. But if you look at that, the modern form of human has arrived on the earth just 200,000 years ago. Chimpanzee, monkeys, gorillas, they were before even us, but still now they cannot use stone, they cannot use even fire. See, like the weaver bird, we tell that they are very intelligent, they make such a beautiful nest, but if you see for 1,000 years their nest has not been improved. So can we tell them the intelligent? For the astronomers, we define the intelligent life or describe the intelligent life as a living species that are capable of receiving, generating, and transmitting artificial electromagnetic wave, namely radio wave. Because otherwise, we cannot recognize or we cannot detect that there exists an intelligent life. So, if the life evolved, the civilization evolved up to that stage where they can receive, generate, and transmit artificial electromagnetic wave, then only the other species in the universe can detect them and can tell them that there exists an intelligent life. In that way, our intelligence is just 150 years old. In 150 years, light has traveled just 150 light year. Okay, it's not very big distance, with a large distance, because our galaxy itself, where we are situated, where we are located in our galaxy, which is from the center, it is just 30,000 light years away, and the age of the galaxy is another 25 light years away. So if there is an intelligent life at the age of our galaxy, it has to be as old as their intelligence, or their civilization has to be as old as 25,000 years, so that we can now receive their signal. Along with this, there is another problem: how life originates, how life originated from Earth. Now, for 50 years, we thought that the building block of life, which is the organic material, that is the nucleotide or the amino acid, that were generated on the Earth itself out of the inorganic material, that is carbon, oxygen, hydrogen, etc., under the electric spark or under the lightning. So there was a famous Urey-Miller experiment that has created organic material out of inorganic material in the laboratory. But nowadays we are getting the evidences from comets, from asteroids, that this organic material can be transported to Earth. And in fact, we have discovered that there is a star, a kind of star called asymptotic giant branch star. So at the envelope of the star at its late stage, it produces copious amount of organic material. So we also don't know whether these organic materials have come from outer space to Earth and then it formed life, or life is formed itself on the Earth. But whatever be the origin of life, we know that the seed of life that might have been imported from outside or might have been originated on the Earth itself, that got a very favorable environment so that it can evolve, it can survive. Now, what type of environment we have? We know one condition, that the temperature will be appropriate so that water can exist in liquid and liquid state. But you will be surprised to know that the configuration of the solar system also supports the survival of life. Now, in our solar system, the rocky planets are inner planets, and the giant planet at the outer side. And out at the edge of the solar system, there is a region, there is a disk belt-like region called the Kuiper belt. All the short distance comets are originated from this Kuiper belt. And beyond this Kuiper belt, there is a region called Oort cloud, where the long term, like the newish type of comet, they are born. Now, these comets, large number, they travel towards the sun in a highly elliptical orbit. Now, they could have collided with the Earth and they could have destroyed the Earth in a very short period. In fact, we know that 60 million years ago, the extinction of dinosaurs and all the other evolved animals on the surface was caused by a collision of a comet. But because of the presence of this giant planet, Jupiter, Saturn, Uranus, these comets are deviating from directly hitting the Earth. These big brothers of the Earth, these Jupiter, Saturn, and the Uranus, they are extending their surface, and the comets are hitting their surface, and thus these big giant planets, these big brothers, are protecting planet Earth from the collision of a comet. Now, the Earth, we know that it has a terrestrial magnetic field, and that also protecting the life. Every second, there is a copious amount of charged particle that is coming out from the sun, and it is traversing towards the Earth. Now, when there is a solar activity, there is a large flare, powerful flare that carries tons of charged material that travels towards the Earth. Now, these flares, if it could have entered into the Earth's atmosphere, it could have destroyed the Earth's atmosphere, its chemical composition, and on life. But Earth has a dipolar magnetic field that is protecting us, that is not allowing this charged particle to enter into the atmosphere. This charged particle can enter only through the open field line and into the pole of the Earth, giving rise to the spectacular aurora borealis. Now, if this magnetic field was not there, then these charged particles, these flares from the sun, would have bombarded everywhere in the atmosphere. It would have made the Earth's atmosphere completely destroyed by changing the chemical composition. It has destroyed the life as well. But because of the magnetic field, we are protected. Now, all of you know that volcanoes or earthquakes are very destructive. They are very dangerous. Earthquakes are very dangerous. They causes a lot of damages. Volcanoes are also dangerous. But do you know, because of volcanoes and earthquakes, the life on the Earth survive? The carbon dioxide in the Earth's atmosphere, that plays a double role. It acts as an agent for reflecting sunlight and thus cooling the planet. At the same time, it acts as an effective greenhouse effect and thus keeping the planet warmer enough for a habitable environment. But when this carbon dioxide mixes with the rainwater, it forms a weak acid called carbonic acid. This carbonic acid, when falls onto the surface of the Earth, it mixes up with the rock and form carbonate, silicon carbonate. Now, given 10 million years, all carbon dioxide would have been dissolved into the Earth's surface, giving rise to carbonate. But because of the earthquakes and because of the volcanoes, this carbon dioxide comes out in the atmosphere, and within 1 million years, it forms a cycle of carbon and silicate that maintains the amount of carbon in Earth's atmosphere, which in turn maintain the ambient environment of the Earth, the ambient temperature of the Earth, so that we can survive. Now, there are dynamical effects also. We know that the Earth rotates in a tilted angle around its own axis. That is, Earth rotation axis is tilted by 23.4 degree. So one precession takes about 24,000 years. Because of this tilt in the rotation axis, we get the seasonal variation. We see summer, we see winter, we see spring. Now, this tilt angle at present, which is 23.4 degrees, also moves from 21.5 degree to 24.5 degree. Altogether, the Earth's orbit also changes from perfectly spherical to elliptical orbit. Its planes also change. Now, together, this dynamical effect that gives rise to a cycle called Milankovitch cycle. So every 25 years, because of these Milankovitch cycles, we see the ice age on the Earth. But this dynamical effect, this tilt in the angle, the variation in the tilt and in angle, the eccentricity, the orbital change, these are very minor, and it takes place in a very long duration. Do you know what causes this small and minor dynamical change? The Earth could have been tilted much larger angle. It could have been changed its tilt angle very chaotically. But because of the presence of a big moon, this is not happening. Now, the moon was not there at the time of birth of the Earth. After 50 billion years of the birth of the planet Earth, a object similar in size of Mars, known as Theia, that collided with the planet Earth. And the planet Earth was almost destroyed, but somehow, because it is much heavier, it survived, and a large amount of material came out from Earth, out of which most of them again settled to the Earth, but a large chunk of object which started orbiting the Earth, and that has become the present day moon. So we have a giant moon, and most likely this moon is originated out of a collision of Theia. Now, if moon was not there, when moon was not there, the Earth was rotating with a high speed. Instead of 24 hours, the duration of the day and night was just 10 hours. And if moon was not there, then the gravitational pull by Jupiter, Saturn, Uranus, they could have made the tilt angle much larger, and there could have been a chaotic change in the tilt angle. But the moon is playing a tug of war with the gravitational attraction of Jupiter, Saturn, and Uranus, and not allowing a greater dynamical change in the Earth's orbit. Now, you know, Mars has only two small satellites, Deimos and Phobos. So its tilt angle is very chaotic, and therefore its seasonal variation is also very chaotic. So the moon, it not only gives rise to tides, and it gives rise to the circulation of the air, but it also determines the seasonal variation, and it makes us to survive. So maybe we do not have 10 moons, we have one moon, but we do not know if 10 moon could have been changed the environment of the Earth. But we are lucky that we have a massive moon which is enabling life to survive, which are providing the appropriate environment in this planet for life to survive. Now, we may not know all this environment, all these favorable conditions in our outer planet or exoplanet. So how do we know that whether a planet harbor life or not? So for that, we will search for biosignature. Now, what are these biosignature? One is oxygen molecule. At the time of the Earth was born, there was no free oxygen molecule. All the oxygen was combined with various other atoms to form carbon dioxide, carbon monoxide, water, and all other things. Now, about 3.9 billion years ago, a bacteria called cyanobacteria, it started doing photosynthesis. It started absorbing carbon dioxide and released oxygen molecules. And all of a sudden, the Earth atmosphere, the chemistry of Earth atmosphere got a huge change, and the Earth become oxygen rich. Now, when this oxygen molecule goes to the upper atmosphere in the stratosphere, it gets hit by the ultraviolet rays of the sun, and it get dissociated into oxygen atom. Now, one oxygen molecule and one oxygen atom combines to form a molecule that is called ozone. Now, because of this ozone layer that is produced by life on Earth, we are protected from the powerful, the energetic ultraviolet rays of the sun. So therefore, the environment is not supported only by the geological and astronomical properties or the condition, it is also supported by life itself. So we will go and search if a planet in its spectrum. We have to first take the spectrum of this planet to find out that if there is a oxygen molecule of there, or there is a ozone molecule, there could be another biosignature which is methane. When living species dies, the bacteria disintegrate it into methane, but methane is under equilibrium of oxygen. In an oxygen rich environment, chemically produced methane cannot survive. It produces water and carbon dioxide. But if there is a continuous production of methane, then we can see the methane is not combined with the oxygen or not reacted much. There will be some additional amount of methane, and that will give the signature that life exists on that planet. But for the time being, our technology is not that advanced. We do not have sufficiently big telescope to find out, to get a high resolution spectrum of a planet of outside the solar system and to detect the biosignature in that planet. But within a decade, at the end of this decade, we expect that the upcoming large telescope will be able to detect such type of biosignature. Now we know already Hubble telescope is already, it is still functioning. The Spitzer has just this year, it got switched off. Kepler is also down. TESS has already crossed 2 years and it is discovering new planets. Its life is extended to another 2 years. Next year, possibly, James Webb telescope will be James Webb telescope will be 3 times larger than Hubble Space Telescope. Then there will be WFIRST telescope, Gaia, and many other space-bound telescope. In fact, I am also collaborating with one such type of dedicated telescope called Ariel, which will particularly detect the spectrum from the atmosphere of planets, and we will search for the biosignature. At the same time, we will have 3 giant ground-based telescope. One is the European extra large telescope, which will be the largest telescope. Then there will be 30-meter telescope, with which we the Indians have a MO, and we are collaborating with the 30-meter telescope with 10% contribution. And there will be a Magellanic telescope. So giant Magellanic telescope and European extra large telescope will be in the southern hemisphere in Chile, but TMT, the 30-meter telescope, will be in the northern hemisphere in Hawaii. So by using all this upcoming facility, I'm sure that very soon we'll find out an answer. But before we find out an answer, let us look back to our planet, our home, where life, let us look back to our home. That's Earth. That's the 3rd planet of an ordinary star called the Sun. An extremely rare combination of astronomical and geological coincidences enable life to origin, survive, and evolve in this planet. From a distance of about 10 million kilometers, this planet looks like a blue marble. But as we move further and further, this planet looks like a pale blue dot floating in the vast emptiness of the sky. A planet so rare, yet so special, so lonely, yet so crowded, so common, yet so unique, so insignificant, yet so great. A mote of dust suspended in the beam of sunlight. But space is dangerous. This wonderful world is exposed to various danger of the space. A collision by a comet or a giant asteroid can destroy the planet completely. A supernova explosion by nearby star in our galaxy can destroy the atmosphere irreversibly. A gamma ray burst, the most energetic astrophysical phenomena in the universe, if it occurs in our galaxy, it can also destroy the Earth's atmosphere. Usually the sun is a very gentleman, it is a very quiet star, but there could be a giant flare from the sun could be extra active, and a giant flare can destroy entirely the Earth's magnetic field and the Earth's atmosphere. Now there are terrestrial danger as well. A super tsunami or a super volcanoes may also destroy the Earth environment, and life could have been extinct. But these astronomical and terrestrial objects, although they are probable, they are very rare. They are very rare to occur. So we need not worry in the next 10 million years about this danger. But the imminent danger is man-made disaster. A nuclear, a chemical, or a biological wear, even if it happens accidentally, it will destroy the Earth atmosphere irreversibly, and in future, no life could form and evolve in this atmosphere. At the same time, the industrialization by civilization that gives to the global warming by emitting excess amount of carbon dioxide. This increase in the carbon dioxide will warm up the atmosphere of the Earth. It will destroy the ozone layer that is protecting us from the ultraviolet emission of the sun. It can break the carbon silicon cycle within a few hundred years. Therefore, we must take the resolution, we must take the responsibility to protect this rarest of the rare planet, this wonderful world, so that millions of children can keep on smiling. চলে যাব তবু আজ যতক্ষণ দেহে আছে প্রাণ প্রাণপণে পৃথিবীর সরাব জঞ্জাল এ বিশ্বকে এ শিশুর বাসযোগ্য করে যাব আমি নবজাতকের কাছে এ আমার দৃঢ় অঙ্গীকার অবশেষে সব কাজ সেরে আমার দেহের রক্তে নতুন শিশুকে করে যাব আশীর্বাদ তারপর হব ইতিহাস
Thank you, Professor Sengupta. To surmise, I must say that it was as if I was listening to a story. যেন গল্প শুনছিলাম it was wonderful, sir. It was wonderful. It was simply fantastic.
Thank you. Can you see me or can you hear me? Am I out of the presentation?
Sir, I can see you and hear you both. I can see you, I can hear you. Just to be on my own language in Bengali, I must say, গল্প হলেও সত্যি. It was wonderful, sir. It was wonderful. For a layman like me, a complete lecture on astronomy without a single equation. It's beyond thinking, sir. It's beyond my comprehension how you did it. Thank you very much.
Thank you.
Now, we at least need to give Professor Sengupta a break of at least 2 or 3 minutes. He's been talking continuously.
No problem. No,
Sir, we
no
know
problem.
that. We know that.
Please
We know that.
start your AK-47.
Now, what we do is we will take out or select questions from the questions you have posted in the chat box, and then after going to the questions, we will select some questions and put it in front of Professor Sengupta so that he can answer you back. Now, since we have a very limited time, we cannot answer all the questions. So, sir, Professor Sengupta, with your permission, if we can do one thing, that if we cannot answer all the questions, we note them down and send you an email so that once you answer us, we can get back to them and give them the answers.
Sure. Or alternatively, what they can do, they can type the question in your website, that is the Skywatchers Association website, and I can answer there itself so that other people can also know the answer and the question.
Okay, sir. Okay. That's a very good option. Very good option, sir. Okay. So first, what we'll do is, I'm going to hand over the session to Dipankar, who will take you through the question and answer session. He will be selecting questions from the chat box and presenting them before Professor Sengupta, and Professor Sengupta will be answering them one by one. Please do not switch on your microphones to ask your questions. Let Dipankar do it for you. And I'm repeating it once again. If we cannot answer all of your questions, as Professor Sengupta has suggested, we will definitely try to do as he suggested, post them on the website and have the answers all together. Thank you, Dipankar.
Yeah, thank you, sir, for a wonderful lecture on this topic. It was really enlightening one, and there are also a few questions, and all of them have been mixed up. There are different types of question in the chat box. So I am going one by one. The first question is from Rupshana Pradhan. The question is, it's not a Rome planet, it should be rogue planet. How does rogue planet form?
The rogue planet forms in the same way the Earth and Jupiter and they are formed. So I probably you know that how the planetary system form. The stars are formed out of the gravitational collapse of a huge cloud of hydrogen and helium. But then when the star is formed, the leftover gas and the dust, that forms a disk around it, which is called a protoplanetary disk. Now the dust particle and the gas, first because of the electromagnetic attraction, they make the protoplanet or the embryo for the planet, and then when they become bigger, they become their self-gravity becomes high, then they start gathering mass by gravitational attraction, and they form all the planets. So it is believed that we know that the gas planets was first formed, the Jupiter, Neptune, Saturn, they were formed first, and then the rocky planet, that is whatever be the dust left over. So that enabled the rocky planet like Earth, Venus, and Mars and Mercury to be formed. So that's why I told you that it's a mote of dust we are living. Now the rogue planet, they are also formed in the same way. They were in the planetary system. Maybe they were in a solar system type of planet where they were further away from Pluto, and there was a perturbation by a nearby star or by a supernova or something like that. So they got detached from that. They were thrown out from that planetary system, and they are floating individually.
Okay. Hope you got your answer. The next one is from Suryakanta Swain, that by using gravitational waves, can we detect exoplanets in future?
Gravitational wave is so weak It needs two massive galactic black hole to generate sufficient amount of gravity wave so that we'll know it. So gravitational wave, when it occurs, if there is a perturbation in the space-time itself, so it will just not, the sun will not emit or the planet will not emit. Its movement will give rise to gravity wave. But gravity wave will be extremely weak. And we are seeing only the infant of gravity wave technology. So maybe I'm not sure because I'm not an expert of gravity wave, but I do what I can see, what I can feel. So we have the telescope, 2-meter telescope, 1-meter telescope. We don't have a instrument that we cannot use it. So I think probably you should ask the question to the people who has expertise on gravity wave detection. And they can tell that whether their instrument has the capacity to detect planet outside the solar system. But to the best of my knowledge, the planets are so small, they are so light. Even if they are 10 times of Jupiter mass, they will be significantly light, so that the gravity wave will be very, very feeble, cannot be detected.
Okay. There is a question from Payal Roy that, sir, is it technically possible to detect exomoons using radial velocity method?
That's a very interesting question. We know now that in the solar system there are several moons. So we are also trying to find out, but mostly by the transit method. The radial velocity method, it will impart such a small, because this will be a many body problem. The planet gives radial velocity to the star. Now the moon is very, very low, very light. So it cannot impart significant radial velocity to the star, but it can impart a radial velocity to the planet. But that will be mixed up with many other effects. But we are searching from the transit method. If there is a modulation in the transit curve, then we can find out, means the time when the planet just touches the disk of the star, or when it just exits the star, at that time a moon can be detected. This method is being followed. But then, as I have shown you in the polarization, I have suggested polarimetric can also serve a tool for detecting exomoon. If a moon, it transits a planet, a giant planet, then if the giant planet in other way it is not showing any polarization because of the symmetry, perfect symmetry, because it is exactly spherical or very near spherical, but again the symmetry can be broken when a moon will transit the earth, and we can see a time dependent polarization. So in the video, when you see the recorded of the video of the polarization, the last motion I showed how the profile will be, the polarization profile will be. So this I have suggested quite early in 2018, 2016 with my collaborator Mark Marley of Ames NASA, and we suggested that instead polarimetry could be a potential method to detect exomoon around giant planet. But so far, we don't think about detecting moon around Earth-like planet. This is technically extremely, extremely difficult.
Okay, and talking about exomoons, there is a question in our YouTube live streaming from Mr. Akash that, sir, is it possible that exoplanet doesn't support life, but if?
Yes, definitely. I think you have seen the movie Avatar, where instead of the planet, the moon has the life. So if the planet is a gaseous planet like the Kepler 22, but it is in the habitable zone of the star, but it has a moon, a rocky moon, then that rocky moon, and if the rocky moon has an atmosphere, then definitely it can be habitable and it can harbor planets. So moon of planets in the habitable zone are good candidates for life.
There is a question from Mr. Anjan Bollov that, sir, as a researcher in this field, what do you think personally that no, how much more time? That's it. Which are the areas needed to enrich to make the communication process to happen fast in near future?
I'm sorry, I could not understand the question. What is the question? What?
Which are the areas needed to enrich to make the communication process to happen fast in the near future?
The communication system among what? Among us and
Actually,
the extraterrestrial intelligent people, or within us? If it is within the extraterrestrial intelligence, we have already the fastest mode of communication, because nothing can moves faster than light, and the electromagnetic wave, that is the radio wave, moves at the speed of light. So we are sending radio wave, like I am a signatory of the Breakthrough Initiative. So we have used the $100 million donated by Zuckerberg, by Yuri Milner, for buying the radio telescope time, and we are looking for signal. But the thing is that we have to detect artificial signal. We have to get a systematic signal, and there is a called, what is that, public interest on that. So we make crowd support. We get crowd support in analyzing those huge amount of data. So right now, what we are facing is not the communication faster or slower. We want the huge amount of data to be reduced. Maybe possibly we have to take in future help from machine language, machine learning, or such type of thing. So as the technology and the computation facilities are improving, that is enabling us to analyze the data more appropriately. And we already have very giant radio telescope, and we are collecting data from that. But there is no other way from an extraterrestrial intelligence to send us the signal to us with a velocity greater than light. If that they can do it, then that will contradict Einstein special and general relativity. And means, in Star Trek and many other places, they imagine extra dimension. Even in Interstellar, they imagine about wormhole and warped space-time. But just note that 500 years ago, we didn't have any car, even motor car, even cycle. And now we are traveling by plane, we fighter jet. So our civilization is by definition only 6,000 years old, and our technological revolution is just 100 years old. So in another 1,000 years, or if a intelligent life exists which has which are 25,000 or 50,000 years old, they might have discovered some sort of way to reach us very quickly by avoiding the straight dimension, that is the three-dimensional procedure, and they can take a higher dimensional, or they can take a subspace. That is a speculation or very nice idea by Star Trek. When Mr. Urf open a subspace, I think, have you heard about Next Generation? So that's a very good idea. We can imagine all those things, but technology overnight cannot improve. One by one we can go. When I was a student like you, I could not imagine even internet or email or anything or this type of net. Within 20 years, there is so much advanced that I can speak through online. You are using mobile phone on all those things. So given time, the technology improves, the civilization improves, unless and until the civilization reaches a stage that it destroys itself. So there is another problem that we are thinking, why we are not getting signal from any intelligent life. There are 200 billion stars in our own galaxy itself. And for searching the unintelligent life, our search is confined within our galaxy. But searching for intelligent life, we can go beyond our galaxy. And there are 200 billion galaxies. But where are they? Where are the intelligent life? It may happen that they become so intelligent that they destroy themselves itself, or they are not very much keen to know about us. We are so insignificant to us. So there are many problems. It is not that the communication, it is the vastness of our galaxy and the vastness of the universe that we are unable to find out the people. We have not even find out any other signal, like any colonization by intelligent life or any nuclear. I think when I was in the Breakthrough Initiative, Yuri Milner asked me a question that just tell within 1 minute what activity in the space extraterrestrial intelligence can do that we can detect them. So I told that if they perform a nuclear explosion, a hydrogen bomb, then immediately we can get emission line instead of absorption line from the star, and we can search it out. But the thing is that subsequently people started searching for such type of emission line and everything, but nothing found, nothing. So far, like it or not, we are very alone. We are very alone. There is no place in the whole universe where help can come in the case that we face a destruction. There is nowhere we can ask that please help us. We are going. Even you see, this is a nano size, half living virus. The COVID-19 is challenging the might of the most intelligent species, and we are so helpless. Can't do anything. So that's the problem. That's why we have to protect this planet. We have to protect this planet so that we can live for another 1 million year at least before we find out a place and before our technology improves so that we can migrate. For now, visit, all right. Migration, impossible.
Thank you, sir. Before going into the next question, I would like to ask the participant or request the participants to please fill the feedback form. The link has been provided already in the chat box here and the YouTube live streaming. Okay. The next question is from Mr. Ranjan Kumar. Yeah, sir.
So just I'm interrupting for a moment. Professor Sengupta,
Yeah.
It's 8:30 now. Can we continue for another 10 minutes?
Yeah, I have no problem. You can continue up to 6 o'clock because I love these questions. This gives the ideas for me also. That
Thank you, sir. Thank you.
I will tell you one story there. Just few days ago, in 10th October, Professor Vijay Bhaskaran, who is the principal advisor to Prime Minister, so he gave a lecture on genetics, on biology. And there I asked the question that who controls the gene? Is there any higher authority? And he took it that this question is very nice, interesting question, so that he can do further research on that. So the question helps me to think about that, to think new direction. But I expect that people will be confined within the topic. They should not ask me what is dark matter or dark energy, because then the answer will be directly no. Because I don't know, neither I talk on a subject which I do not have expertise on that.
Thank you, sir. Thank you very much.
Please continue.
Okay, sir. The question is from Mr. Ranjan Kumar that is it possible to search for habitable planets near AGB stars based on their organic residuals?
No, see, the AGB star, asymptotic giant branch star, is the end stage of a normal star. So because it has already exhausted its all the fuel, the hydrogen has already combined into helium, the helium has started burning and the star has started expanding. It has become very big, it's a red giant stage, and after the red giant stage, this asymptotic giant branch takes the form. So having a planet around the AGB star is not possible. But what I'm telling, why I told about the AGB star, because when the AGB star gets destroyed or it throws out all these organic materials, it adds up with the interstellar cloud. Out of that interstellar cloud, a star is born, a planet is born, and that planet is organic molecule rich. The same way we got gold, we got all the higher element. See, when the universe was created in the Big Bang, we have only hydrogen and helium and a little bit of lithium, nothing else was there. So the higher element up to the carbon was synthesized inside a star. Now, when the star got destroyed, there was if it was more massive, at least 10 to 20 times more massive than the sun, then it exploded into supernova. And during that supernova, gold, uranium, and all those higher elements were born. And those material that got spread into the interstellar medium, out of that interstellar gas, the star like sun, which is the second generation star, was formed. And thus our solar system, our sun, is rich in higher elements. So this silicon is also from AGB star. We knew that thing for a long time. So the AGB stars and all the stars that contribute. So what you see in your hand, the carbon, that has been synthesized in a star. the organic material that might have been synthesized on Earth or might have come from outside. So in that way, we are all cosmic. And when the Earth will be destroyed, the sun will become bigger, or red giant, or in AGB star states, Earth will be destroyed. All this carbon and materials will be spread out over the interstellar medium. Then out of the gravitational collapse, new star will be formed, new planet will be formed, new life will be formed, and this cycle will go on. So just like na hannate hanna manante, nothing can be destroyed. The basic thing of the life cannot be destroyed. In fact, even if Earth is destroyed, some of the extremophile which is hidden in the rock may also survive. They may land into another planet, and they may also start evolving, giving rise to planet. So this is a very fascinating, very philosophical aspect of our world.
Thank you, sir. There is a question in our YouTube streaming from Mr. Tuhin Jana, that is it totally impossible that a civilization develop without liquid water and carbon?
Well, a civilization, no, your question should be if life can be developed. Civilization comes from life. Without the answer is we do not know, because we do not know if, as I have told you in the beginning when I was replying what is life, if life can be formed out of other molecules, other elements, or if by other biological thing, we do not know whether the laws of biology are same or not. But the problem will be we cannot recognize that that is the life unless and until that is the intelligent life and come to us and tell that, send a message that look, we are also life but made of different composition, different biology. In that case, it will be proved that the laws of biology are not unique like the laws of physics.
Thank you, sir. There is a question from Mr. Biplab Das regarding the atmosphere of Jupiter, that I have heard that instead of water, Jupiter rains with diamond. Is it true?
The question is that you should tell where you are hurt. Before answering the question, I must say to all the young people here, I think the organizer, every time they give a very good suggestion about what to do and what not to do. Without verifying the authenticity of any news or any information, please do not share, forward, or circulated any news in social media. The spreading of fake news could be damaging to individuals and damaging to the society as a whole. But now coming to Mr. Biplab's question, which is, I think he has read from any newspaper, which may not be a fake news, which may be a right news there, because under the temperature, the Jupiter can form silicon, and that silicon can form diamond. There is one paper, but nobody took it very seriously. There is no observational evidence so far that there is a diamond ring. So often what happened, the media highlights such type of question. See, if I simply tell that there is a ammonia rain, there is a silicon rain, no media will take. But if I tell there is a gold rain, media will tell, and it will go to you. So it will be better when you get a news, just ask the question. Is it possible? How diamond can be formed in Jupiter atmosphere? Then it will come to you that how diamond is formed. So diamond is formed from carbon. So if there is silicate thing, then how the silicon can be formed? There must be some dust. Where this dust can get the temperature and pressure to form the crystal? So that type of analysis will give you the answer by yourself itself. You need not ask a scientist on that. But for the time being, I have also read that in news, in media. I went through those papers that is not published in a peer-reviewed journal. So right now, I do not believe or do not accept. If there is more evidences, see, the science, the beauty of science is that it is a self-correcting thing. I will tell anything and nobody will believe it. The thing is that the beauty of science is that you need not believe in it. If you believe or if you don't believe, the truth will be truth. So if really there are diamond, there is a possibility of diamond, it can be detected, it can be observed by other people also, and it will be established by other people. Thank you.
There is a question. It's not a question. It's a request rather. That sir, you have used Drake's equation in your book. Will you please elaborate on it?
I cannot elaborate here now. The equation tells the possibility of life and intelligent life to exist. So I have given in my book a sufficiently elaborated form. So I don't know where I don't have in my slide, but again I have to go back to presenting and all those things. So it is not possible for me to elaborate Drake equation here. Drake equation is determined the possibility of the existence of life by considering how many stars are there in the galaxy, how many stars have planets, these are all probability. How many planet should be like Earth type of rocky planets? How many planets should have been in the habitable zone? How many habitable zone can have organic material and form life, and how many life can evolve into intelligent life? That's all. And it goes on, but because many of these probability, these quantities are not known, so there is an estimation, and they tell that half of the about 100 billion of planet exist, and out of that 50 billion will be like Earth, where the life can form. But for a scientist, these are all speculative thing. I cannot specifically tell. Drake equation is a motivation. It was given in in the 60s decade. That has initiated the search for intelligent life. It has encouraged the government to spend some money. So this Drake, Occam, and Carl Sagan, they formed a group, and they started first this SETI and the search for intelligent thing there. So Drake equation is just an empirical equation. It has no verification. The quantities involved are not known right now. So we cannot tell what should be the solution of this equation.
Dipankar,
Huh.
can I ask a question?
Yes, sir.
Just continuing your line of discussion just now, we look for extraterrestrial life or alien intelligence, artificial intelligent life. We seek signs or signals of what they do normally or what they have done. My point is, are we doing anything? We means earthlings, people of the earth. Are we doing anything to make us visible and detectable to them?
Yes, sir. Very interesting question. The thing is that if you happen to go outside the solar system, you will find out that out of all the planets and including Sun, Earth is the most radio loud planet. And the extraterrestrial intelligence will be very much curious, because our TV signal, our radio signal, that penetrates the ionosphere and goes far, far away. So and with the particular frequency, particular wavelength and everything. So they will be very surprised that how these radio waves are, who generated. And very soon they will understand that these are not natural radio waves. These are all artificial radio waves. At the same time, when Voyager was sent, Voyager 1 and 2, I think at the same time your organization is also formed.
Right,
so
sir, right.
Voyager sent some message that containing our coordinate system and embedded in a golden disk. And we are also sending radio burst for our signal, for our coordinate and for our thing there. So with the hope that if that radio signal can be intercepted by any intelligent life. But the thing is that, again, even to reach the Proxima Century, our nearest star, it takes 4 years. So if we have sent that signal, say 40 years ago, it has reached only 40 light years. So we don't expect intelligent life so nearby. But of course, the Earth will be a very interesting object for any extraterrestrial intelligence. If they happen to graze nearby, they will see that an extraordinarily radio loud planet is there in the solar system. And they will very soon they will detect that these radio noises, they are not natural, they are artificial. But when they will approach us, as I showed you, they will find out us as a pale blue dot, then they will find out a blue marble. Then as the height of International Space Station, they will see cloud and water. They have to come much below to see the structure, the straight line, the triangle of our paddy field, to decide that there are some intelligent people are doing. Keeping in mind, they are searching the source of this radio wave. But then when they will come more down and down, they will find out our buses, our minibuses, our taxis, and they will think that those are the intelligent life. But then they will see that some insects are coming out from those, and those are us. So it will be a very surprising thing for us to find out who are these intelligent species that is generating this radio, the radio noise. So I think Carl Sagan Cosmos and the pale blue dot has very nicely described how extraterrestrial intelligent, when they will approach the Earth, they will find us.
Thank you, sir. Thank you very much.
I think I should take one more question here. There is a question from Bhagyasri Vilor that how do we measure mass of an exoplanet?
So the Doppler shift, that is actually a gravitational effect. So how much the star is moving towards you and towards going you, that gives rise to the projected mass of the object. Because we know you put in Kepler's law, you can know that if you know the mass of the star. So if we know the mass of the star, we can find out that what is the projected mass, that is m sin I, projected mass of the planet. But this projected mass will depend on the inclination angle, which cannot be determined from the Doppler effect. Now, the same planet is monitored through transit method, which gives the information about the inclination angle, about the radius and everything. So from that inclination angle, we can find out the exact mass of the planet. Otherwise, from Doppler or radial velocity method, we can only measure the maximum mass of the planet. Now, once by transit method, we know the radius of the planet also. We can find out the mean density of the planet, the surface gravity of the planet, and then we can find out whether the planet is gaseous or it is rocky in nature. So it is because of the radial velocity, which is the gravitational effect of the planet, that gives this radial velocity. And the gravitational effect is, of course, that gives rise to the mass. Because of the mass only, this gravitational effect on the star is visible.
Thank you, sir. And with this question, I would like to ask Shoykot sir to please do the ending sessions and further proceedings of this webinar.
Right. So, Professor Sengupta, thank you once again.
Thank you.
There is no doubt that this was a lecture which we can say a lecture on science popularization at its best. A layman, you got me a layman highly interested in what you were saying. And you got me to ask a question even. That shows how successful you were.
Thank you.
I just want to mention one thing in your lecture.
Encouraging. These are very encouraging, and I'm glad for these comments. I hope that the other participants will also put their comments and criticism in Facebook or other ways, so that in future I can improve it. And this is the outcome of many people, like my students has made some of the animation. My collaborator in JPL and Caltech made some animation that I modified into video. And to reach the public, you have to avoid the technical term, because the goal of me is to make as many people science aware, that in Bengali, which we call Bigyan Monosko. So if in your organization, through your program, if 500 people attended, out of that, if 20 people got interested, they become sign-minded, that will be my great success.
I definitely know that you are successful. No doubt about it.
Thank you.
Now, just before handing this session over to someone who will conclude the session, I want to mention one point in your lecture where some of my friends, one of my friends interrupted you to say that the YouTube live had a snag. And with no second thoughts, you recapitulated the entire thing. Thank you very much, sir. This sort of quick response is simply great, sir. Now, I'd like to hand over the session to Mr. Subroto Manna, who will formally end this session by offering you the vote of thanks. Subroto. Subroto da.
Namaskar, sir. Yes, sir.
It's,
In
You
our
are to-
fourth webinar today, we hopefully had our Honorable Professor Sujan Sengupta as our lecturer. Sir, this is our privilege to have you in our new web platform webinar. We are very much thankful to you as you have managed your valuable time from busy schedule to be a part of our program. We are actually mesmerized as you have wonderfully discussed the topic, the exciting exoplanets. Are we alone? To our young astronomer, astro lover generation who are very much interested about your presentation speech. You know, it is the mostly interesting and discussed science topic in all over Earth, as everyone is eager to know about alien. I think each and every participant has gained more and more interest about this matter. I am sure that you will accompany us in future and manage your time to encourage and enlighten our members and sky enthusiasts. Our young members of Skywatchers Association are trying to develop a new sensation on the field of astronomy towards the science mongerer of our country with you. I very much appreciate their efforts. Lastly, I convey my gratitude once more to you, sir, along with all our members of Skywatchers Association, Kolkata. Thank you, sir.
Thank you very much. I am also very much pleased and very much glad. Thank you, Mr. Dipankar De, and
Thank you, sir.
And your team. Very nice that 2 days ago you have taught me how to use this webinar, how to use Google Doc. You have been very expert, very responsible, and I hope that the effort, the tradition of the Skywatcher Association will continue, and it will emerge out as one of the leading organizations in West Bengal to spread astronomy, to spread science among the people. It will spread the rationality among the young mind. Whenever there is any need or any help is needed, please contact me. You have my number, you have my Facebook account, you have my email. I will be more than glad to help all of you. Thank you.
Thank you, sir. Thank you very
sir.
much.
Thank you very much. Sir. Thank you very much. দীপঙ্কর,
হ্যাঁ স্যার।
তাহলে আমি তোকে কোয়েশ্চেন গুলো, যেগুলো চ্যাট বক্সের কোয়েশ্চেন, আমি তোকে মেল করে দিচ্ছি।
হ্যাঁ, বাকিগুলো আমায় মেল করে দিন। হ্যাঁ,
ঠিক, ওকে। আর তুই ফোন কখন করবি? এক্ষুনি না তো?
একটু পরে, একটু পরে।
তাহলে ধর এখন বাজে 6টা, 7টা।
হ্যাঁ, ঠিক আছে।
ওকে, ওকে, ফাইন। তাহলে আমি বেরোচ্ছি। সবাইকে বলছি, আই এম লিভিং দ্য মিটিং। থ্যাংক ইউ এভরিওয়ান ফর বিং উইথ আস, এন্ড প্লিজ বি উইথ আস ইন ফিউচার। We have many exciting programs.
Okay, so that's the end of the webinar. So the participants can leave the meeting. Thank you very much for being with us.
Thank you very much.